References are what make Excel's world work. To get this far, you've used references and relied on them. However, your knowledge about them is probably fairly limited. Most formulas you write will use references, but not all of them. If I write equals 1 plus 2, I've written a formula that contains no references. Excel rightly evaluates that to 3. Now, if I change this to equal A1 plus B1, I've done the same thing since I have a value of 1 in A1 and a value of 2 in B1, except now I'm using references. Going a step further, we just covered named ranges. A1 happens to have a name and B1 contains a name too. These are top-level references. Local 1 refers to A1, which contains a value of 1. Local 2 refers to B1, which contains a value of 2. What if I told you that a named range could actually contain a function that calculates what its reference is, or that you could write a formula in a cell to calculate what the reference should be before actually referring to that cell, and that the calculation could contain references of its own? Such capabilities vastly extend Excel's versatility, but we need to learn a bit more about how a formula works for it to make sense, and in doing so, I'll also show you a few more tips and tricks along the way. Formulas work in a step-by-step process. Let's look at a slightly more complex case to explain this. This is an if statement that calculates A2 plus B2 if C1 is 1, but calculates A1 plus B1 otherwise. We have many different references here and a number of implicit operations. Each reference in this formula starts out as what's called a range object, which means that every property of the cell is contained within the reference. The characters A1 represent a pointer to cell A1, which has a font type, a height, a width, a row, a column, a formula, a value, and dozens of other attributes. Excel looks at the command A1 plus B1 and interprets this as wanting the value from A1 plus the value from B1. For now, this is a little bit more detailed than is necessary, but the key point to take away is that A1 does not represent just a value of 1, but instead acts as a pointer to an object with dozens of pieces of information, one of which happens to be a value of 1. Since a reference is only a pointer to a range object, it is possible to calculate a reference given a set of inputs using a variety of different functions. The functions that we will cover in this course are the indirect, offset, and cell functions. The indirect and offset functions return new references, something that we'll use to a great extent, while the cell function allows you to extract various bits of other information from a cell outside of its value. Along the way, I'll also discuss the row and column functions to help us with our functions. But for now, let's look at a quick trick that I'll use quite a bit in this chapter. Within our formula, I can look at how individual pieces of the formula will calculate by going into the bar, selecting the piece I want, and pressing F9. This tells Excel to evaluate the selected area. If I highlight A1 and press F9, I see the value of 1. I can then select B1, press F9, and see the value of 2. Alternatively, I can select the whole set A2 plus B2, press F9, and see the sum of 9. Excel completes only the steps that you highlight when doing this, so this can be great for trying to figure out why an error is occurring in a formula if you're not sure of the source. You can break it down bit by bit to see where the problem lies. Beware though, you are technically editing the formula as you do this. If I press enter, I've just committed these changes to the formula so that the references have been lost. Of course, I can press Ctrl Z to undo that change. References make Excel very powerful, and we're going to learn how to manipulate them formulaically. This will make charts easier in our next chapter, and it will give us a way to enhance our named ranges beyond their current functionality. We'll start this in our next lesson with the simplest function to understand, the indirect function.